Hello my dear students, welcome back to my channel Essential Academy Chemistry with Vinay. In this video, I am going to share about a trick box of electrophilic substitution reaction. There are two important tricks that you should remember. This is your trick number 1, followed by one more trick. If you observe in this chart what I am just sharing for you, where benzene reacts with H2SO4, acetyl chloride, methyl chloride or alkyl chloride, a chloride, concentrated HNO3, concentrated H2SO4. Here, two things you should remember, children. This is number 1 and this is number 2. Two things you need to memorize. I'll just tell you what is the trick here is. If you go for an electrophilic substitution reaction, wherever you come across anhydrous aluminium chloride, you just see all these four: anhydrous aluminium chloride. Whenever you come across an anhydrous aluminium chloride with acetyl or alkyl or Cl2 or in the presence of chloride, when benzene undergo reaction in the presence of anhydrous aluminium chloride, fix in your mind, it always undergo electrophilic substitution reaction. This is first thing that you should remember. Other than anhydrous aluminium chloride, remember H2SO4. One is concentrated H2SO4 and concentrated HNO3, as well as only H2SO4. So whenever H2SO4 is there, that is also coming under electrophilic substitution reaction. Remember anhydrous aluminium chloride with benzene, they all are undergoing electrophilic substitution reaction. In the presence of H2SO4 and concentrated H2SO4 and HNO3, that is also an electrophilic substitution reaction. This is one part that you need to remember. The second part that is very important is here about the sulfonation. So if concentrated H2SO, that is H2SO4 is heated with benzene, only H2SO4, then it is sulfonation. If it is H2SO4 as well as concentrated H2SO4, then it is nitration. Remember children, nitration with concentrated HNO3 and concentrated H2SO4. Whereas in case of sulfonation, concentrated H2SO4 only. Now, if you observe here, whenever I say acylation, remember about acetyl chloride COCl, CH3COCl. Whenever it is alkylation, try to fix this, that is CH3Cl. Halogenation, either it may be adding of excess of halogen or halogen, only 2 times of halogen. Both are halogenation reaction. So always remember, number 2, sulfonation, Friedel-Crafts reactions, halogenation reactions, nitration reactions, they all come under electrophilic substitution reaction. Two things you have to remember. Whenever you see anhydrous aluminium chloride with the benzene, they are electrophilic substitution reaction. Concentrated H2SO4, that is also an electrophilic substitution reaction. Here you need to remember only what you are taking here as a reagent or a reactant. That is reagent anhydrous aluminium chloride. Whereas here you need to remember the names also. It's the second important point. Sulfonation, Friedel-Crafts reactions, halogenations and nitration. Remember, S for sulfonation, F for Friedel-Crafts reaction, H for halogenation and N for nitration. All these reactions, they always give you electrophilic, they undergo electrophilic substitution reaction. They are all are electrophilic substitution reaction. This is number 1, a very important information. Remember always, whenever you come across anhydrous aluminium chlorides, reacting with a benzene, that is a reagent, then you can directly just make it as it is an electrophilic substitution reaction. This is number 1. Let us go for the next thing. This is the super trick box of number 2. This is a trick box number 2. Remember, this is also a very important one. It helps you a lot to solve a second type of question. In this, the questions are going to be based on if it is ortho or para directing groups. If it is ortho or para directing groups. Remember, if it is ortho or para directing groups. If it is ortho or para directing groups, like which are those groups? I'll just show you which are those groups are. So these are the groups. These are known as ortho and para directing groups. If you observe all these examples here, you can observe all these groups are ortho and para directing groups. Whenever these are present on the benzene ring, remember children, whenever these groups which you are seeing them in an order, when these are present on the benzene ring, they always increase the electron density. It is very, very important. When the electron density increases, it is going to undergo electrophilic substitution reaction at a faster rate. Remember, once again I am going to repeat, these are ortho and para directing group. When these are present here on the benzene, you can observe it is increasing the electron density on the benzene, due to which it is going to be most reactive towards electrophilic substitution reaction. It will become most reactive. Very, very important, children. Next, you just observe here, we have a meta-directing groups. Meta-directing groups means these are the one NO2, CHO, COR, carboxylic acid, COOR, SO3H, CN. All these groups are meta-directing groups. Whenever these groups are there on the benzene ring, you see there is no any lone pair. It is not going to increase the electron density, but in turn it decreases the electron density. Because of these groups, because they are meta-directing groups, when these are present on the benzene, they will be very less reactive towards electrophilic substitution reaction. Very, very, very important, children. You can take a screenshot of it, and now straight away we'll make use of these two boxes and solve the previous year's question paper. Hope you all are ready. Yes, let us start now. You can observe here, children, in this question was asked in NEET 2020. Which of the following compound is most reactive in electrophilic aromatic substitution? So this question can be solved very easily by using the trick box number 2. I'll just show you the trick box number 2. You can observe here. If you observe, you compare the groups. What are the groups that is being attached to the benzene ring? If these groups are attached, they make most reactive towards electrophilic substitution reaction. If these groups are attached, they make less reactive towards electrophilic substitution reaction. So now let us see what are the groups present. So if you observe here, the groups are present here. Definitely NO2. NO2 is a meta-directing group. Definitely it decreases the electrophilic aromatic substitution. So it is not possible. Now it's a comparison between the OH, the benzene and Cl. Remember, children, the OH is going to come first. You can observe here, the OH comes first, then comes a benzene, then comes fluorine, then comes chloride, then comes bromide, then comes iodine. So according to this chart, according to this order, first comes OH. If you observe here, children, This OH, what you are observing, it has a capacity to form a phenoxide ion. It can form a phenoxide ion, because of which the electron density on the benzene increases, and due to which electrophilic substitution reaction will become most reactive. And then we have benzene, and then we have chloride. So the most reactive is going to be what? Is going to be D. Hope you have understood this question. If you have got any confusions, do comment and clear your doubts, children. We'll take one more question quickly. One more question. This is the last question in this video. You can observe in this question, children. It's a very interesting one. If you observe in this question, so what do you observe here is, this is the one which has been asked in 2019, NEET 2019 question. So how to solve this one? Among the following reactions, the one which proceeds through a electrophilic substitution. So among these reactions, which one is going to be an electrophilic substitution reaction? You know the first one, this is a preparation of a chlorobenzene or a aryl halide by a diazonium salt. This is not a electrophilic substitution reaction. This is the C. If you observe, this is also not an electrophilic substitution reaction because it is a free radical substitution reaction. And even this is also not a electrophilic substitution reaction. As I had told you, whenever you see anhydrous aluminum chloride is present, therefore definitely this is a electrophilic substitution reaction. This proceeds with electrophilic substitution reaction. I just had shown you this box where you can observe whenever there is an anhydrous aluminum chloride, they always undergo electrophilic substitution reaction. Whenever you see a H2SO4 or concentrated HNO3 with H2SO4, that is also electrophilic substitution reaction. Sulfonation, Friedel-Crafts reactions, halogenation reactions, nitration, all these are electrophilic substitution reaction. Very important thing. And there are some of the questions that you may get in the future where which of the compound will be meta-directing, which of the groups will be ortho-para-directing. So even this is going to be a very important information where you can solve the second type of question that is based on electrophilic substitution reaction. This is all. That's all in this video, children. For more videos, subscribe to my channel, do comment, click on the like, and I will be getting still more interest to make more and more videos and post it. Thank you. See you again.